Here were a few problems that dealt with simple gram to mole conversions on your test. Remember, you don't have to memorize stuff. All you have to do is just lay out things according to dimensional analysis, and everything from there on out is visual. Okay, we're going to convert 1.39 grams of beryllium. We start with what we're given to moles. Now, we have to go to the periodic table to see what is the molar mass of beryllium, and it is 9.012 grams per mole. So 9.012 grams on the bottom per mole on the top. Okay, so remember, I didn't have to sit there and say, am I going to have to multiply, divide? I wasn't doing anything like that. All I was doing, I said it's 9.012 grams per mole. Where does grams have to be to cancel out so I can end up with moles? Because that's the whole goal here. I end up with 1.39 divided by 9.01 moles. Now, we don't have to actually go through the math in this, because as you can see, none of your answer choices would match except for this one. You know that you're going to get a number that's less than 1. But we'll go ahead and do it anyway. 1.39 divided by 9.012 is going to give me 0.154 moles. Okay, the next one, I'm going to start with what I'm given. 2.7 times 10 to the 18th atoms of beryllium to grams. Okay, again, I've got a couple relationships here. I've got Avogadro's number, which 6.022 times 10 to the 23rd grams per mole. Atoms per mole. So I'm not going to sit here and think, do I want to multiply or divide? I'm just going to say, what do I want on top? I want atoms to be on the bottom so I can cancel it. So I'm going to say 6.022 times 10 to the 23rd atoms are in 1 mole of anything. Okay, and then I'm left with mole here. I'm not done yet because I want to convert it to grams. So from the periodic table, I've got 9.012 grams per mole. Again, I don't want to sit here and think, do I multiply or divide? I just say to myself, what unit do I want to be on top? What do I want to end up with? I want to end up with grams. So let me just put 9.012 grams on top and mole on the bottom. Now, I haven't thought much. I'm just going to, not touching my calculator yet, I'm just going to look at my units. I already have my atoms canceled, my moles cancel, and when I'm finished with this problem, I'm going to end up with grams. So I can feel very comfortable at this point knowing that I set my problem up correctly. Alright, actually this has the wrong unit written in the problem. It should be grams, I think, or maybe not. Let's see. So when I do something like this, I'm just going to say, look at this EXP button here. Make sure you're pushing that. A lot of people do something weird, like say times 10 with an exponent caret button to whatever, and you're going to get your problem wrong if you do that. Watch how I push this in. I say 2.7 exponent 18 divided by 6.012 0.022 exponent 23, and that gives me 4.5 times 10 to the negative 6 moles of something. Alright. The problem asked you to convert to grams. Looks like I'm going to end up having to drop this problem from your test because I probably meant to put moles right here, and also these numbers aren't quite matching out. Let me just follow this through, but I'll drop this one from your test. So we're going to take this and we're going to multiply this number by 9.012 grams, and we get 4.05 times 10 to the negative 5th grams. Okay, so it should have been this answer, but the problem with this question was I had the wrong units here, so I'll drop that one because if you know, that could have caused some confusion for you, so that would be an extra point on the test. But if I would have had grams here, then that question would have been just fine. Okay, here, what is the mass of 8 moles of sodium chloride? We got to step it up just a little bit because now we've got to know what the formula mass of sodium chloride is. Sodium, from my periodic table, is 22.99, 23. Chlorine, 35.45, so I'm going to say 35. So I've got 23 plus 35 gives me 58 grams per mole for sodium chloride. Now, I look at my answers here. I do not have to be worried about significant figures because all my numbers are far away from each other. So significant figures is not a problem. I don't have to worry about all those little tenths and hundredths digits. I want to know mass. I start with what I'm given. I've got 8 moles. Now, again, I'm not thinking, do I want to multiply or divide? I'm just saying grams is here, and I want to end up with grams. So I can say 58 grams per mole. So my grams is on top, moles is on bottom. Moles cancel. I end up with grams. So I'm pretty sure I got my problem set up correctly. Now, here, there's some, I probably don't even have to use my calculator. You know for sure that it can't be, you've got 8 times 60, so it's going to be in the neighborhood of 480, right? So there's no way it's going to be this one. There's no way it's going to be this one. Alright, so I've got these two answers right here, 468 grams and 468 moles. Okay, so what I'm going to do is I'm going to look back up here in my question, and I'm going to see that the mass is what I'm actually looking for. So my answer is 468 grams. Okay, the next one is I want to know how many molecules are in 3.6 grams of sodium chloride. So I start out with 3.6 grams again, I've already figured out that it's 58 grams per mole. So I say to myself, well, I want to get rid of grams, so what do I do with this number? I'll put 58 grams on the bottom, mole right here, okay. Actually, this word ought to be formula units instead of molecules because it's an ionic bond. Now, I also know Avogadro's number, and I'm not going to want to sit here and say, what do I do, multiply or divide? I just want to say to myself, what do I want to get rid of? I want to end up with formula units, not moles, so I want to get rid of moles. So I'm going to put 6.022 times 10 to the 23rd, and I'm just going to say formula units on the bottom. Molecules is just easier